You're all here in spite of the downpour that just occurred at the very moment this talk is scheduled. So I'm thrilled that you're here. We're also thrilled to have Sandra Steingraber here with us this evening to speak on the topic, First Environment, Women's Bodies, Trespassers. My name is Holly Blake, and I'm director of the Women Involved in Living and Learning program, better known as WIL, here at the University of Richmond. Tonight's talk is the first in the WIL WGSS Quest speaker series for this year, the theme of which is environmental justice. Our speaker series has always tackled difficult issues for which there are no simple solutions or even common understandings of the underlying problems. Our hope is that the series serves as a starting point for discussion and connection, that the series inspires you to learn more and to take action based on this knowledge, to do something to address the problems about which we are learning. That is what the WIL program is all about, connecting theory and practice, connecting and applying classroom learning to the world outside the classroom. And we have 5 more events to follow in our environmental justice series. And the next one is Bernice Miller-Travis and University of Richmond Professor Andrea Simpson, and they will give a presentation on Wednesday, October 25th at 4, entitled A Woman's Worth, Race, Gender, and Class in the Environmental Justice Movement. And at the back at this table here, we have flyers that has information about the entire series. So please take that information and share it with friends. I also want to let you know that there's information available about and from the Susan G. Komen Breast Cancer Foundation. So please look at that literature and take anything there that you see. For helping to make this series possible, I would like to recognize and thank Quest, specifically Julie T. and Kathy Hewitt-Smith, the Booker Chair in Religion and Ethics, thanks to Scott Davis for his sustained support of our series over the years, the Center for Civic Engagement, the university's Cultural Affairs Committee, the Environmental Awareness Group, and here I'd specifically like to recognize Chris Stevenson for his support of the series and his suggestion of Lois Gibbs, who will be speaking next semester. The Gottwald Speakers Board, the Office of Student Development, the Department of Political Science, in particular Andrea Simpson and Dan Palazzolo, the Sierra Club, the University Chaplaincy, West Hampton College, WGSS, with thanks to Dorothy Holland. I'd also like to thank Karen O'Connell, the Administrative Assistant of the WIL program, and Melissa Uten, the other Director of WIL. Following tonight's talk, Sandra Steingraber will answer questions. So when you have your question, please speak loudly so we can all hear. And we also have copies of 3 of her books. Living Downstream, an ecologist looks at cancer and the environment. Having Faith, an ecologist's journey to motherhood, and post-diagnosis. So cash, check, and credit cards are accepted. and Sandra, sound like a little ad. And Sandra's happy to stay afterwards and sign copies. Okay, now I'm pleased to introduce 2 WIL members who will in turn introduce our speaker. Whitney Witherspoon is a senior majoring in Latin American and Iberian Studies with a minor in Human Gender and Sexuality Studies. As well, she is the president of Ngoma African Dance Company and vice president of Delta Sigma Theta. Becca Fraser is a sophomore with majors in cognitive science and leadership studies and a minor in women, gender, and sexuality studies. In addition to this, she's a member of Stealing Home and is active in Alpha Chi Omega. So please welcome Whitney to Becca. Thanks.
Thank you very much, Dr. Blake. Before we introduce our speaker, we thought we'd share a little bit of background information on Sandra and her accomplishments. Sandra Steingraber received her doctorate in biology from the University of Michigan and her master's degree in English from Illinois State University. She is well accomplished in her field and is a living testimony to her works as an author, ecologist, mother, and cancer survivor. Her first book, Living Downstream, An Ecologist Looks at Cancer and the Environment, takes a look at cancer as a human rights issue and merges data on toxic releases with data data from U.S. cancer registries. This book has also been hailed as a moving personal document and a triumph of scientific detection, and a book that reminds us of the intimate connection between the health of our bodies and the integrity of our air, land, and water.
Having Faith, an ecologist's journey to motherhood is her second book. In it, Steingraber explores the intimate ecology of motherhood. Among other things, she looks at the environmental hazards that now threaten pregnant and breastfeeding women and examines the effects these toxins can have on a child. One review of this book calls Having Faith an essential text not only for environmental health scientists, advocates, and future parents, but for all of those who care about the health of our future generations. In addition to these insightful works, she has also briefed the UN delegates in Geneva about breast milk contamination. She has received numerous awards, including being named Woman of the Year by Miss Magazine in 1997, the In the Life of Service Award given by the Jennifer Altman Foundation in 1998, and she was honored with the Excellence in Medical Communication by the New England chapter of the American Medical Writers. Currently, she is a distinguished visiting scholar in residence at Ithaca College in Ithaca, New York. Without further ado, we are happy to present to you Dr. Sandra Steingraber.
Well, thanks for that really warm introduction. It's just an honor to be here and be the inaugural speaker for your great series. I would love to come back and hear each and every one of your speakers. Lois Gibbs is a friend of mine, actually, and I know you're in for a real treat, so I really encourage you to come and hear what Lois has to tell you. And I also know it's a lot of work planning a program like this, so thanks to all of my sponsors here at in Richmond, because whenever a crowd is assembled and a speaker is flown across the state lines, a lot of work has to go on behind the scenes to make all that happen. Publicity and mailings and announcements on NPR and all the rest. So thank you to everybody. Also gives me a chance to publicly thank my undergraduate ecology professor, Lou Berner, who is here in the audience, much to my incredible surprise, who is now a wildlife biologist here with the state of Virginia. He suddenly showed up in my life. So if you see him shaking his head and going like this, you know I made some terrible biological mistake up here, so I'm going to try not to be intimidated by you. All right. When I was at the brink of 40, I had already spent 20 years as a childless adult, and most of those years were lived out as an ecologist, which meant I spent a lot of time thinking about how organisms interact with the environments that they inhabit. So it might not come as too much of a surprise if I tell you what my reaction was to finding out I was pregnant. And you know how this is done now, right? You go to a pharmacy and you buy a home pregnancy test kit, and inside that kit is a plastic stick that you pee on. Only the stick is called the wand, which I present to you women's studies majors for some sort of exegesis on what that's all about, right? It's a little wand. And so you pee on the wand, which is embedded with monoclonal antibodies who bind with the antigen in a pregnant woman's urine, which is called human chorionic gonadotropin. And when the antigen and the antibody bind, there's a color change. And you see two purple lines on the stick, and then you know that there's two of you and not just one of you anymore. Your whole life is not going to be different. So when I peed on the stick and saw the two lines, one of my first thoughts was, I'm a habitat. I'm now an ecosystem. And I became really fascinated by thinking about this environment inside my uterus, this inlet ocean in which was swimming around my unborn daughter. And so, and because I think a lot about environmental threats to other habitats, I got really interested in thinking about what kind of toxic chemicals might be trespassing across that open doorway of the placenta and entering this little world and confronting my unborn child with a toxic assault, and what would that exactly mean? So I moved from Boston to Cornell University to begin research for the book out of which I'm going to talk tonight, which is my more recent book, Having Faith. Most of you know I'm a cancer survivor, and I'll leave it to you to think about why a person who's had cancer who goes on to have a child might name that child Faith. And I moved to Cornell because they have a really great fetal toxicology program, which is the field of study that I became very interested in. Fetal toxicology refers to the toxic chemicals exposed, that expose life before birth. And so the book is kind of two books in one. It tells the story of my pregnancy with my daughter Faith and my very ecstatic experience with labor and delivery and my breastfeeding relationship with her. But along the way, those personal memoiristic events kind of open up a little space for me to talk about the science of fetal toxicology. So my English professors always told me after the introduction to present the thesis statement of my essay, so I'm going to go ahead and give that away to you right away. And those of you who are compelled to write papers about this topic, you can start taking notes now. Essentially, what I discovered is that the new science of fetal toxicology is mounting a challenge to the old ways of regulating toxic chemicals, which is based on an idea that goes way back to the Middle Ages. In the Middle Ages, there was a monk named Paracelsus, who was also a physician. He was Swiss, but he changed his name to a Latin name to sound very learned, which is the kind of style of the day. And he treated lots of people with sexually transmitted diseases, particularly syphilis, and he treated them with mercury, which he thought erroneously was curative. But he noticed correctly that if he gave too much mercury to the patient, it killed them. So he coined this phrase, the dose makes the poison. The idea being, which is not true, that something could be beneficial in a small dose, but could be poisonous at a larger dose. And this idea kind of carried on through the Middle Ages and through the Enlightenment and on into the modern era and became the kind of paradigm of toxicology. So that when we discover through careful scientific study that a chemical of some kind is inherently toxic, let's say it breaks chromosomes and might be related to cancer, or gets into your brain and interferes with your neurological impulses, or it contributes to a miscarriage or something like that. Instead of immediately moving to look around for a substitute for such a toxic chemical, instead what we do is try to figure out how much of the toxic chemical is needed to have a demonstrable effect. And we do those studies usually on laboratory animals and then factor in some sort of safety factor. And then we allow the chemical to be out there to be used, whether it's a pesticide sprayed on crops or something you put in fingernail polish or lipstick or household paint or something that you manufacture in large volumes in an industry like polyvinyl chloride or something like that, which is vinyl plastic. So the idea is that none of us then become exposed to too much of these poisonous things. So we have this sort of vast policing system by which we measure toxic chemicals in everything from lake sediment bottoms to Cheerios. And that's kind of how we do things, and that's how the Europeans do things as well. But what fetal toxicology is now showing us is that it's the timing that makes the poison as much as the dose. So it turns out that as we go through a human lifespan, we enter into periods of time where some critical event unfolds in our bodies. And fetal life is just one of these times. And during that window of time, if a toxic chemical enters our story, the effect can be way disproportionate to dose. So that the timing turns out to be equally important to dose. Let me just give you one quick example. All of us in this room have something called the blood-brain barrier, which stands between our circulatory system and the actual gray matter of our brain. And it actually works pretty well if you are exposed, let's say, to a trace amount of an insecticide in the dinner tonight, which is a neurological poison. All insecticides are. And your blood-brain barrier stands between your blood and your brain so that that chemical cannot enter your brain where it can do some real damage. And so if you're exposed to just a few parts per billion in a week of bug killer, let's say, probably the effect won't be harmful to you. However, you don't get a blood-brain barrier until you're 6 months old. That's how long it takes for it to develop. So a newborn baby is missing this whole suit of armor that the rest of us have around their brain. So a tiny, tiny exposure to a newborn, especially since their brains are just getting wired together, can be worth a much bigger exposure to a toxic chemical later on in life. So I think there are profound human rights implications to this discovery, this science, because what it means is we have set regulatory limits, these maximum tolerance levels of toxic chemicals for middle-aged young adults. We haven't taken the very young into account. It also turns out that your blood-brain barrier becomes more permeable after the age of 70. So our elders are also missing a defense mechanism that we younger people have. So on both ends of the age spectrum, it turns out that we are discriminating against the very young and the very old in the way we set our toxic regulatory, the way our policy is on environmental chemicals. It also, I believe, there's evidence to suggest that teenagers are another vulnerable subpopulation that we're also discriminating against. If I have time in my remarks, looking at the biology of adolescence is something that is part of my current work, and I'll be talking a little bit about that. So let me kind of go through some basic embryology with you so we can see how some of these anatomical and physiological events unfold. And we'll go back and rewind the tape to take a look at what happens when a toxic chemical enters the fetal story. So here's the part of the lecture where I get to tell you where babies come from. So if the parents did a really bad job, certainly not at least you can leave tonight saying that you want to leave on that part of things, biology straight. Okay, so when an egg and a sperm find each other, that happens at the upper reaches of the fallopian tube. And it takes about a week for that fertilized egg to float down this Venetian canal of the fallopian tube before it kind of bobs out into the delta of the uterus. And during that week, you go from one cell, so when egg and sperm, right, each have 23 chromosomes, they combine, they're now one cell big, and then it starts dividing. So by the time the week is over and this new life form is out in the middle of the uterus, you've moved from one cell to 58 cells. And that's called a morula, which is Latin for mulberry. That's what it looks like. The next thing that has to happen is a successful implantation of the morula. And it really is like planting a seed. It buries itself in the lining of the uterus, which is called the endometrial lining. That's the part that you see during menstruation. And when it lines the uterus, it's very, very rich in blood vessels. And so what the morula does is send out long siphoning tubes that have enzymes at their tips. The enzymes break open the tips of the arteries that spiral through the endometrial lining. And little geysers of blood start spurting and form a little lagoon around the morula. And so life really does begin in a puddle of blood because something has to nourish the morula before the whole life support system of the pregnancy can get established. The next thing that happens is the establishment of the whole kind of space capsule that the little miniature astronaut is going to be tethered to for the rest of the pregnancy. These are the extra-embryonic membranes. If you had any biology at all, some of this should sound familiar. The amnion, the chorion, the allantoic sac. Eventually these structures end up forming things like the umbilical cord and the placenta. So you have to grow those structures first before you can actually assemble a human body. So that goes on for a while. And then at about week 5, as obstetricians and midwives date pregnancies, we enter a new phase of pregnancy that's called organogenesis. And this is the actual formation of the human body. And it's more like Japanese origami than it is sculpture. Essentially, the morula, what goes on inside the morula, is this sort of flattening out of this ball of cells into 3 flat tissue layers. And again, if you have it all, endoderm, ectoderm, and mesoderm are the names of those 3 tissues. Some of you are nodding, so that's good. And what happens then, you have to roll these things up or fold them up to form 3-dimensional structures. And that goes on between week 5 and the end of week 10. And at the end of week 10, essentially, you have a complete little human being the size of a paperclip inside the uterus, and all the body parts are present. And the rest of pregnancy, which is about 40 weeks long, represents the growth and development of all those body parts. So I'm going to kind of fast forward through this part now, except to mention one little interesting event that happens in the 2nd trimester of pregnancy, in the 5th and 6th months of pregnancy, when the brain goes through this huge spurt of development. All the neurons of the brain were formed during organogenesis. But what the hallmark of being a human is that you have incredible numbers of connections between your neurons, way more than all other life forms. And the way that happens is that the neurons have to move. They migrate through the skull, and they meet up with other neurons that are also moving. And every time they meet, they spin a web of connections. So if you can kind of imagine a spider, you know how spiders can rappel down the length of their own silken axon. That is how brain cells move inside a fetal skull. So they spin out a fiber called an axon, and then the brain cell actually travels down that fiber until it meets up, let's say there's another brain cell They meet, and then they spin this whole web of connections that are called dendrites, and then they continue moving and meet up with other migrating neurons and keep spinning and spinning and spinning until every neuron is connected with literally millions of other neurons in the brain. And you have all these sort of pathways that the neurons are traveling. The early migrating neurons actually leave some kind of messages for the later migrating neurons to follow. So you have the ones that blaze the trail, and then lots of other neurons start following them. And through that process, the whole architecture of the brain begins to take shape. The neurons continue to migrate up until you're 2 years old, and then they stop. And then between the age 2 and 3, a lot of those connections are actually pruning back, which turns out to be important because in order to have an attention span and to be able to focus on something, you actually can't have too many neurons firing at once. And learning and memory actually depend on pathways following familiar pathways and not kind of getting lost in this whole electrical network. So the pruning back process that happens between age 2 and 3 is also important as much as the development of all those pathways. So that all begins in earnest in months 5 and 6 of pregnancy, and then continues after birth until at least the 3rd birthday. Okay, so then about week 40 starts the very dramatic events of labor and delivery. And at that point, the symbiotic relationship between the mother and child is ruptured, and the baby simply is living on air for a while. The normal, healthy neonate comes into this world with enough food and water on board to last about a week, if it needs to, without eating or drinking anything. So whenever you see those reports of terrible earthquakes and 2 or 3 days pass and there's the hope for survivors grows dim, oftentimes one of the last living people they pull out of the rubble is a newborn because they're actually able, their evolution has allowed them to be born with this ability to last for a long time without needing to eat or drink. That's a great adaptation because what goes on inside a woman's body is this kind of massive demolition and reconstruction project by which all that blood flow that is directed down to the uterus, which increases by 50-fold during pregnancy, that all has to be redirected up to the breast so that the breast can take over from the uterus, from the placenta, the job of not only nurturing the baby but helping to guide its development. And it takes about between 2 and 5 days for that to happen. So somewhere between 48 hours after birth to 5 days after birth, the woman experiences her milk coming in, and then the symbiotic relationship between baby and mother is reestablished again for as long as breastfeeding continues. And I want to mention that breast milk has in it not just food, but actual growth factors and hormones and living white blood cells that provide disease protection because all mammals are actually born immune incompetent. They can't fight off diseases. So the antibodies in the living white blood cells in a mother's body gets into her milk and allows disease protection to the nursling, which is why breastfed babies don't get sick as often as their formula-fed counterparts. But more interesting to me actually, data showing that there are growth factors that help guide the development of the brain. So that whole migration thing that started happening in utero that goes on after birth is facilitated by 130 different molecules called oligosaccharides, which is a kind of a sugar that's not digested, but passes through the gut of the infant, goes up into the brain, and actually is like the places on the trail that continue to guide the brain cells to where they should be. Thus, breastfed babies have better vision, better hearing, higher IQs actually when they become school children and even adolescents. So if you're breastfed as a baby, on a population-wide level, those who are breastfed as babies go on to have fewer learning disabilities. They actually have higher academic scores than those who were fed infant formula. They also have better balance and coordination, and they hit developmental milestones sooner, like they learn to sit up sooner. So the benefits of breast milk for the development of the brain are really impressive. Now, I was adopted, and so I never had a drop of breast milk in my life, as far as I know, and I managed to stumble through this world anyway. So this is not to impugn mothers who are unable or were not empowered to nurse their babies, but definitely based on the evidence that I was able to gather on what breast milk does for health and development, I certainly chose to nurse my own 2 children for quite a long period of time. My daughter nursed for 3 years and my son for 4 years, so I lactated actually continuously for 7 years. And my son actually just recently, he said he was now more interested good basic biology. So let's rewind the tape and take a look at what happens when chemicals that are toxic come in here. So we'll go back to the egg and the sperm. Chemicals can affect our fertility. That's the first thing they can do. We know, for example, from studies of women who smoke, that smokers go into menopause sooner than women who don't smoke because of benzoylpyrene, which is for you chemists out there, that's a polycyclic aromatic hydrocarbon found in tobacco smoke that when it gets into your bloodstream will go right into your ovaries and kill eggs in the ovaries through a process called apoptosis. So women who smoke have fewer viable eggs than women who don't smoke, but they shorten their fertile lifespan after smoking. That caused researchers to wonder, since benzoylpyrene is also found in air pollution, whether or not air pollution itself may be affecting women's fertility. And I don't have an answer for you yet on this question, except to say this is a hot area of research right now. We know when we contaminate laboratory cages where female rats are living with levels of polycyclic aromatic hydrocarbons that are similar to the levels that we see in some of our major cities, we get death of eggs in the ovary at a shortened fertile lifespan in rats by the same mechanism that we see in smoking women. So now there is research ongoing in places like Eastern Europe, Beijing, and Los Angeles, where we see lots of this kind of air pollution, to ask whether or not women's fertility is being compromised through air pollution. Benzoylpyrene is a big component of coal burning. So coal burning power plants are a big emitter of it. So the question I want to raise here, we don't have absolute proof yet, but it's an ongoing question. What's the connection between our ability to get pregnant and when we enter menopause and our energy policy? Everything that Dick Cheney and Mr. Coney sitting around talk about. Now that's the connection that most people don't make in their minds. Something very private. Age at which you don't menstruate anymore. Age at which you might or might not be able to get pregnant. And how much of our electricity is generated by coal. In fact, there may be a connection between the very intimate and the very private and the very public. Sperm are not immune to damage from environmental toxins either. We know that men in Missouri who drink water, drinking water is contaminated with pesticides. These men are not farmers, they just live in rural areas and drink contaminated water. They have lowered sperm counts and more damaged sperm than other rural men whose wells happen not to be contaminated. And the question is whether or not that actually interferes with their fertility. So the ongoing study is to take a look at a subset of those men who are actively trying to impregnate their partners to see if it takes longer, more months to achieve pregnancy in men with higher levels of pesticides in drinking water than men who are drinking cleaner water. And again, these are studies that are ongoing, so I don't really have answers for you yet. What I can say is we have pretty good data showing that there is a link between certain kinds of childhood cancers and male exposure to certain chemicals. So that men exposed on the job to kerosene, diesel exhaust, and a few other chemicals, this is preconception now, will go on to sire children that are at tenfold risk for rare pediatric cancers. And again, we don't have worked out the mechanism of that yet. Have these chemicals damaged the chromosomes of the sperm, and those sperm go on to fertilize the egg, leading to a human organism that has certain kinds of genetic damage right from the get-go that somehow predispose them to rare cancers? We're still trying to figure out what the connection is there. But let's assume that there is a healthy sperm and a healthy egg. They get married, they go on the honeymoon down the fallopian tube, and then the next thing that has to happen is implantation and the setting up of all these extra embryonic membranes. If a toxic chemical enters our story at this point, the danger is pregnancy loss. That life support system doesn't establish itself correctly, the pregnancy won't continue, the embryo will die, and it will be flushed out of the system. A woman experiences that as a miscarriage. In the scientific community, we call that spontaneous abortion. Some of the strongest evidence we have comes from studies of a pesticide called methoxychlor, which appears to raise the risk for miscarriage. And we've actually identified the mechanism by which it does. It interferes with the burial of the morula into the endometrial lining through interference with a parahormonal signal. And that leads to miscarriage, and so women exposed to methoxychlor often have lots of repeated miscarriages. We also have evidence linking solvents to miscarriage, and the strongest data there come from women who work in the computer chip industry, who are using lots of solvents to clean the chips. That has led researchers to wonder if nail salons might be worth looking at, because some of the same solvents that are used in Silicon Valley to make manufactured computer circuit boards are also used in nail salons, often as glue removers and things like that. And there are also other nasty things in nail salons, epoxy resins, that we know from studies of animals do interfere with pregnancy. So the question is, and again, I'm not saying nail salons cause miscarriages, but I'm saying that we have evidence from animal studies to suggest they have that power in other mammals, and it's an active area of concern right now in the public health community. This is a tricky to study because most nail salons in this nation are run by Asian immigrant women who often don't speak English. They do tend to be young women of reproductive age, so in their clientele, and they're working at very close up with these chemicals. Are not wearing hoods, they're not under hoods, they don't have ventilators. You know, the kind of protections that workers who actually manufacture these chemicals would have are not present in nail salons. So that's an active area of research. And I want to say that I'm going to be talking about early pregnancy loss at a conference at the University of San Francisco Medical School in January. And we're going to be looking at a lot more of the evidence, looking at other kind of chemicals to this. And I'm interested in talking to the medical community about it, but I've also been interested in talking to the Right to Life community about this. And I've just started doing this. And it seems a little bit of a tricky conversation to have, a real high wire act. Tell me what you do with this. This is how I'm trying to pitch it. All right, so let's see. Let me say it this way. I want to have a conversation about abortion with the Right to Life community, but not necessarily about, what I want to do is impress upon the Right to Life community that abortion means more than just a woman walking into a Planned Parenthood clinic and choosing to pregnancy. It also can refer to toxic chemicals that trespass into her body in pregnancy. And I think that the Right to Life community should be interested in that. I don't know if they are. Maybe they're more interested in controlling women's reproductive lives and not really about the environment. But it's a conversation that's worth having. And I actually suspect there are elements within the Right to Life community who would find this compelling. So I've tried out some of this in some of the red states that I've lectured, and so far so good. I've gotten hollered at a couple times. But what I usually say is I lay all my cards on the table. I find that's the most effective way. And to say, look, I'm firmly a member of the pro-choice camp. I've had an abortion myself. And I'll often explain my reasons for having the abortion. The pregnancy that I had before faith, early ultrasound showed it was certainly not going to end happily. So my partner and I made a really difficult decision to end that pregnancy. Because so much of my family is in the fundamentalist Christian community back in Illinois, I had a big decision to make because I had already told everyone that we were pregnant, and now I had to tell them that we weren't. So I could just say, well, we lost the pregnancy and let people assume I had a miscarriage. It wouldn't really be a lie, but it could affect it would. Or I could be honest about it and explain what happened and our reasons for doing it and let them say what they're going to say. So I chose the latter path, and much to my amazement, I discovered that one by one, women in my family, as well as in my husband's family, called me back and told me the stories of their own abortions. So it's turned out that nearly every woman in my family has had an abortion, some without the protection of Roe v. Wade. And some under, still sworn to secrecy about the identity of some of these women, so I'll just tell you in general some of the stories. One of them was in her 40s and thought she couldn't have children, and her husband was already showing the early signs of a dementing disorder that it would ultimately kill him, but she ended up being his caretaker for 25 years, so she wasn't prepared to have another child. One woman had rubella, which a lot of you aren't old enough to know what that means, but I was 10 years old when the vaccine finally came on the market. Rubella is German measles. It's a very mild disease, but when German measles crosses the placenta, it's a very, very powerful birth defect causing agent. And if you have rubella when you're pregnant, the chances are very good that the baby will be born blind, deaf, cardiac defects, and mentally retarded. So the last big rubella epidemic was in 1964. That's when my husband's mother became pregnant with her 5th child. My husband was a child number 4. And she had rubella and chose to seek out an illegal abortion. One woman was 13, another woman was 50. You know, all these women have this kind of compelling stories. So what I say to my Red State audiences is that, look, you know, you can agree or disagree with me about whether or not we made ethical or moral decisions. Here's something else I want to tell you, and then I'll lay out the evidence from the adoption floor and other chemicals that can end pregnancies, and that those pregnancy losses are just as real as abortions, and oftentimes they happen to very much desired pregnancies. And it seems to me that those who are interested in the sanctity of prenatal life might want to wrap their minds around some of this new evidence and consider it. All right, let's go on. Let's assume that the pregnancy there's no miscarriage, everything's fine so far. Now we enter week 11, and that's when the human body's going to start to form. The danger here is different. The danger here is actually a physical malformation, or what we would call a birth defect. The human body is just getting itself put together. And an embryo develops from the head down and from the center out. So we know usually with some precision when something must have gone awry to arrive at the birth defect that we see. So if it's a cleft palate or lip or hole in the heart, that happens very early on in development. We're near that 5-week mark. If we see missing or webbed fingers and toes, undescended testicles, that usually happens more near the 11-week mark. We don't always know what happened to cause the problem, but we do have some clues. And some of the best birth defect registry data actually come from Europe, so I'm going to be citing European data here. So in countries like Finland and Spain and Italy, we know that women who work in farming or in floral shops or in greenhouses or nurseries have higher than expected rates of particular kinds of birth defects than in children. Those are women who are being exposed to pesticides. And then when we look at the data from the U.S., California has a pretty good birth defect registry data, and we see a really nice relationship. Well, I mean nice in that biologically nice, not that's good. Yeah, the closer a woman lives near a farm field where pesticides are used, the higher her risk for a fatal birth defect. The farther away she lives from the field, you see risk dropping off. We have some really good data from Minnesota showing higher rates of birth defects, not only in the rural agricultural areas of the state than in the urban and suburban areas, but also we see a seasonality to the data, so that babies who are born in rural areas and who have birthdays in the late winter are at much higher risk than their siblings born to the same parents in the same place, but whose birthdays fall at different points in the calendar year. And when you do the math, you realize that those babies with late winter birthdays are the ones